In today's class, we'll cover electric dipole. It is defined as an electric dipole is formed when 2-point charges of equal magnitude and opposite sign are separated by a small distance d, as shown in the figure. This q and q are of equal magnitude, but their sign is opposite. Okay, this is called as dipole separated by distance d. We will find out the electric potential due to this q1 minus q at this point P and as well as the electric field due to these two charges at that point P. Okay, in the last chapter we have covered V is equal to, that is electric potential at a given point is equal to K into Q by R volts, where K is equal to 9 into 10 to the power of 9. It is a constant. It is nothing but 1 by 4 pi epsilon naught. If you substitute the values, you will get this value. And Q is the point charge and R is the distance between Q and the given point. Okay, let us apply this formula for Q1 minus Q as well as, and then find out the total electric potential at P due to Q1 minus Q, that is due to dipole. Okay, I already defined what is dipole. It is a formed when 2-point charges of equal in magnitude and opposite sign are separated by a small distance d, as shown in the figure. So the potential, electric potential due to Q, so sum of electric potential due to Q as well as minus Q, I will write here. Due to Q is K into Q by R1. R1 bar is a vector, whereas R1 is its magnitude, minus K into Q by R2. So which is equal to K into Q into 1 by R1 minus 1 by R2, which is equal to K into Q into R2 minus R1 by R1 R2. Assuming that this R is much greater than D, then R1 R2 is approximately equal to R square. And what about this R2 minus R1? Let us drop a perpendicular here. Perpendicular. This is theta is the angle between this position vector R and the z axis. That is the angle between dipole as well as this R. Okay, assuming that this angle is same, let us consider this triangle, and this length is R2 minus R1. R2 minus R1 is this length. Okay, in this rectangle triangle, cos theta is equal to adjacent side by hypotenuse. So R2 minus R1 is equal to d cos theta. D cos theta. Let us substitute here now. That is R2, this is approximately equal to, not exactly. Why? Because theta is not exactly equal to this theta, since these two are not in parallel. So approximately equal to d cos theta. So R2 minus R1 is approximately equal to d cos theta. Let us substitute these values now in this expression. So V is equal to K into Q. R2 minus R1 is d cos theta by R1 R2 is R square. Let us define the dipole moment P, which is equal to Q into D. That is charge into displacement between the two charges Q and minus Q. This is the dipole moment. Okay, its vector form is P into AZ cap, since P is along the Z axis from minus Q to plus Q. So vector P is equal to P into AZ cap. AZ cap is the unit vector in the Z axis, in the direction of Z. So V is equal to K into, that is Q into D is nothing but P. Q into D is P. K into P cos theta by R square. R square. That P cos theta is nothing but dot product of P and theta is the angle between this position vector R and the dipole moment, that is dot AR cap. Dot product of these two will give P cos theta. Let us do that now. Dot product of P dot AR cap is equal to magnitude of P into magnitude of AR cap into cos of the angle between these two. That is angle between this position vector R and vector, that is P bar is theta. So this is equal to magnitude of P bar is P only, magnitude of AR cap is 1. So we will get P cos theta. So P cos theta can be done like this, P bar dot AR cap. So it is equal to K into P bar dot AR cap by R square. But any vector, for example, let us consider R only. Vector R is equal to its magnitude into unit vector AR cap. So AR cap is equal to vector R by its magnitude R. So let us substitute that here. So we will get V is equal to K into P bar minus R bar by R square into R. We will get R cube. Square into R is R cube volts. That is when the dipole center is at the origin of the coordinate system. This is the formula. V is equal to K into P bar dot R bar by R cube volts. Okay. If this dipole center is not coinciding with the origin, then let us find out now. R is the distance between the center of the dipole and the given point. Now we are moving this R, we will move this C in the upward direction, let us say. Then we will see what we will get. And let this point be minus Q and let this point be plus Q, and the distance between these two is D. D is the distance between Q and minus Q, and center is, whose position vector is R1, let us say. R1 from origin, center, and P is here, and P is whose position vector is R now from origin. Let us find out the position vector. Let us find out the position vector from center to P. Let it be X, vector X. Vector X. We should find out the X now and substitute in place of R in here, in this equation. So what is X? R plus X. R1, this is R1, this is R bar, this is X bar. R1 bar plus X bar is equal to R bar. So R, that is vector X, is equal to vector R minus R1. So let us substitute here now. When the center is not at the origin, it is away from the origin by R1 in the Z axis, in the upward direction. So in place of R, we can write r minus r1. That is r bar minus, in place of r we can write r minus r1, and in here the magnitude is r bar minus r1 whole cube. That is when the center is at a distance r1 from the center of the dipole is at a distance r1 from the origin. This is the equation to be considered. Now let us find out the electric field due to this dipole at this point. Okay. For dipole, it varies, the voltage varies inversely, voltage inversely proportional to r square for dipole. If it is a monopole, it is inversely proportional to r. Since it is a dipole, it is voltage is varying as 1 by r square. That is, V is directly proportional to 1 by r square. Let us find out E now. E. Let's find out E. In the last chapter, this equation E is equal to minus del V is covered. Minus del V is covered. Okay. Where here V is equal to K into QD cos theta by R square. K into QD cos theta by R square, where R is the position vector of the point from the center of the dipole. Center of the dipole. Let us find out the electric field now. So this electric field is also a vector. So E is equal to minus dV by, since these coordinates are r theta belongs to spherical coordinates. Those are r, theta and phi. Phi is not there in this expression, so we will consider only these two. So minus dV by dr into ar cap plus dV by r into d theta a theta cap. Okay. Let us find out the first term and second term and then add these two terms. Let us differentiate this expression with respect to r first and with respect to theta. With respect to r, let us derive with respect to r. So that is d by dr of k phi d cos theta is equal to, let us take out the constants, only we are differentiating this with respect to r. So this is equal to k cube d cos theta into d by dr of r square, nothing but r power minus 2. This is equal to k into qd cos theta minus 2 by r cube. Minus 2 by r cube into ar cap. Into ar cap. Then second term d dv by r into d theta into a theta cap, which is equal to here with respect to theta I have to differentiate. So I will take out common 1 by r into d by d theta of v, this expression, into d by d theta of k qd cos theta by r square. These constants are k, qd and r square. Let us bring out the, so 1 by r cube bring out this r square into k q d into cos theta d by d theta of cos theta into a theta cap, which is equal to k qd by r cube into minus sin theta into a theta cap. Let us substitute these now in this expression. We will get E is equal to minus 2. E is equal to minus of dv by dr. dv by dr we will get this expression. So it is equal to k qd minus 2 cos theta by r cube into a r cap plus k into qd by r cube into minus sin theta into a theta cap. So which is equal to E is equal to the vector. E is equal to open the brackets and take out the common kqd by r cube. kqd by r cube into 2 cos theta ar cap minus sin theta a theta cap. This is the final expression for electric field, which is equal to k into p by r cube, where p is the dipole moment. P is equal to q into d. 2 cos theta ar cap, here it is plus, minus, if I open the brackets, minus into minus 2, minus into minus 1. So we will get plus here, ar cap plus sin theta a theta cap. So the electric field for a dipole is inversely proportional to r cube and the voltage inversely proportional to r square. For a monopole, that is for a point charge, the electric field is directly proportional to 1 by r square and voltage directly proportional to 1 by r or inversely proportional to r. So we will do some numericals on this topic so that you can clearly understand what is dipole. Two dipoles with dipole moments. Two dipoles with dipole moments. Minus 5 az cap, minus 5 az cap, minus 5 az cap, nanocoulombs meter, and 9 az cap, nanocoulombs meter are located at points 0, 0, 0, 0, minus 2, and 0, 0, 3 and 0, 0, 3. So these 2 points, the dipole are located respectively. Find the potential at the origin. Find potential at the origin. That is P at the origin. P is at the origin. Two dipoles are given. We have to find out. So we know that V is equal to sigma K is equal to 1 to N. Here two dipoles are K is equal to 2. 1 to 2. Pk dot Rk. Pk dot Rk by Rk cube. By Rk cube. This is small k. This k is equal to 9 into 10 to the power of 9, which is equal to 1 by 4 pi epsilon naught. So V is equal to k into P1 dot R1 by R1 cube plus P2 dot R2 by R2 cube. Let us find out P1, P2 and R1 and R2. This R1 is nothing but the magnitude of this vector R1 and R2 is the magnitude of vector R2. And given P1 is equal to minus 5 AZ cap and P2 is equal to 9 AZ cap. Given nano coulombs per meter. Nano coulomb meter. Nano coulomb meter. These are the units. Nano means 10 to the power of minus 9. P1, P2, R1. Let us find out R1 now. R1 is the distance between P1 and origin. That is R1 is equal to, so what is R1? 0, 0, 0 minus 0, 0 minus 2. So R1 is equal to 2 into AZ cap and R2 is equal to R2 is equal to should be R2 is equal to 0, 0, 0 minus 0, 0, 3, which is equal to minus 3 AZ cap. Minus 3 AZ cap. Let us substitute these values now and P1 is given. So V is equal to K into what is P1? Minus 5 into AZ cap in dot R1 is what? 2 into AZ cap divided by R1 cube. What is R1? Its magnitude is 2 only and its magnitude is 3. That is R1 is equal to 2 and R2 is equal to 3. Magnitude is 3. So R1 cube is, what is R1? 2 cube 8 plus P2 is P2 9 AZ cap dot P2 into R2 bar is minus 3 AZ cap divided by R2 cube. What is R2? 3, 27. The dot product of these two is, since These two are unit vectors. Mod A Z cap into mod A Z cap into cos 0. Angle between A Z cap and A Z cap is 0. So it will be 1. Cos 0 is 1. So it is equal to K into minus 10 by 8 plus this is minus 27. Minus 27. AZ cap magnitude is 1 into 1. AZ cap magnitude is 1. AZ cap magnitude is 1 into cos of angle between these two is 0. So minus 27 by 27, which is equal to K into minus 5 by 4 minus 1, which is equal to V is equal to minus 20.25 volts. Minus 20.25 volts. Okay. This, the dipole, electric dipole is completely covered. Thank you.